Hello and welcome again to my physical science online video lecture and lab supplement series. Today's video is a post-quiz review for my physical science lab class, the reaction time lab. So here's how this is going to work since it's the first one of these for the lab class, and since not everybody who takes the lab takes the lecture and vice versa, I'm going to pull up this screen, which is basically the item analysis for this quiz. And it shows a variety of things: how many points possible were there, how many questions were there, what was your average score, how many people actually attempted this, etc. And the thing that I'm going to do is I organize the questions by difficulty, and I pick a few of these questions based on that difficulty, and I'm going to work through them for you. So it looks to me like for this particular lab, the most difficult questions were all calculated numeric. I guess in the lab, based on one quiz worth of analysis, maybe doing calculations is harder than answering multiple choice questions. We'll see if that trend continues. So let's look at these questions. I notice the average score in the lab is just shy of a 68. That is with 25 completed attempts. There's actually about 30 people in the class, so that's maybe dragging the average down a little bit. Looks like the average time spent on this was a grand total of 20 minutes. That's, I guess, good news in the sense that you had something like 2 hours to complete this test, so it looks like everybody had plenty of time to do it. And of course you all had 2 tries to do this in. So let's look at maybe the 3 most missed questions on here. So let's open these sort of each in turn. So whoops, I forget that when I click on these it does something silly where it just opens the analysis again, unless I just click directly on these. I don't know why it does this. So let's take this first question. It says that your friend drops a meter stick and then you catch it and you repeat 5 times, and then you have different fall distances that the stick has fallen. It wants to know what your average reaction time is for this experiment. The other one looks like you drop the stick, it falls a certain distance for each hand, and you want to compare how much faster one hand was than the other, and that's again in time. And finally, it needs a percent difference calculation for 2 times. So let's look at each of these questions in turn. We'll start with this one, the dropping a meter stick, catching and repeating a few times. By the way, in answering this one, I can also answer another question that was asked on this lab, which was basically what is the average of these fall distances. So let's do both just for fun. Alright, so let's make ourselves a little table just for fun. So we'll have the distance column and we'll have the time column. Distance is how far it falls, time is how much time that takes, and basically we can even have a sort of average column at the bottom. And actually, instead of doing it like this, let's create 2 distance columns. One will be the distances as shown here, that is in centimeters. One can be the distance in meters, and one can be the time in seconds. Now, you don't have to do it exactly this way, but for me this is maybe the easiest way to organize this information. So the distances given: 17 centimeters, 16, 13, 7 again, and 12. And in each case it's a 0.0. The question is, what is your average reaction time? And we have to first figure out the time and then average these times. Just as a simple warm-up, let's have a sort of an average down here for each of these categories. And remember that if you want the average, you'd represent that by, basically, if you're doing for measurement x, it's x with a bar over it, and it's 1 divided by the number of measurements that you made times the sum of each individual measurement that you made. So from I equals 1 to n, x sub I is how this would look mathematically. That may look like a kind of scary equation to a lot of you guys because you're not used to working with sort of this form of symbols. All this is saying is this symbol is a capital sigma. It basically means sum. X sub I means individual measurements of x. And 1 over n just says when you've finished doing that, divide by how many measurements you took. So as our simple example, we'll take these 5 measurements. So have 5 measurements, and therefore n is equal to 5. These right here represent the individual measurements. So you could call them like x1, x2, x3, x4, and x5, if you would like to think of it like that. So you've got your 5 measurements, and basically you've got to add them together and then divide by 5. So this looks like 1/5 of 7.0 centimeters plus 16.0 centimeters plus 13.0 centimeters plus 7.0 centimeters plus 12.0 centimeters. Okay, so if you want at this point, you can have a calculator to do this. And so we have 7 plus 16 plus 13 plus 7 plus 12. And it says that the answer is 55. So this means your average fall distance is this, and so therefore your average fall distance is 1/5 of 55 centimeters. So if you divide this number by 5, you get 11 centimeters. We can even keep the 0.0 for significant figures. And you can also convert this into meters by moving the decimal place over 2. So 0.110 meters. So we can write 11.0 here. We can put 0.110 here. These ones, basically you just move the decimal over 2 in each case. So 0.07. This one right here, 0.16, 0.13, 0.070, and 0.120. So that is it in meters. The reason why I'm converting it into meters is because now we can actually go about answering this question. This, by the way, I think answers one of the other questions that's on your test, which is what's the average fall distance. In any case, it shows how to do some other question on your test. So in order to get this right here, we first have to convert distance to time. So 1 convert the individual distances or the individual x's into individual times. And to do that, we use the equation that I gave you in the lab handout. I'll pull that up. So this is where the equation is written. If I scroll up a little bit, here's your reaction time lab handout. So time in seconds is square root 2 times distance in meters divided by 9.8. So what this equation really looks like is that you can say T is equal to square root of 2 times D over G. So this right here is time is equal to square root 2 times distance divided by 9.8. But notice that the equation said specific units. Distance is in meters, time is in seconds. So because this distance is in meters, it's useful to have these sets of distances. So let's try it out for the first one. I'll work the first one explicitly, and then I'll just fill in the answers for the other ones. So T1 is going to be equal to square root of 2 times your distance, 0.070 meters, divided by the 9.8. For what it's worth, that's actually in units of meters per second squared. Alright, so the order of operations here that you have to follow, you go 2 times 0.07, then you divide that by 9.8. So this first, then times this, then divided by this. When you've done all that, then you push your square root button, and here's what the square root is. So this right here just said that it's approximately 0.1195 etc. seconds. 952 seconds, for example. So I'll keep that to maybe 3 significant figures, 0.120. Okay, so now I'm going to go ahead and get these other 4 without showing all the steps here, because I just showed the steps and I'm just doing the same thing over and over and over again. So to make it a little faster for myself and for you who are watching, I'm going to do that now. Okay, so here are the individual reaction times. Last but not least, we have to do step 2, which is now get the average. So T average is, in this case, 1/5 of all of these times. 0.120 plus 0.181 plus 0.163 plus 0.120 plus 0.156, and all those times are in seconds, so I'm going to put the seconds out here. So let's add all those times together. We have 0.120 plus 0.181 plus 0.163 plus 0.120 plus 0.156. So that gets us 0.074. So the average time, oops, didn't mean to make that little streak. The average time is 1/5 of 0.74 seconds. So if we divide 0.74 by 5, we get 0.148 seconds. So this average time is 0.148 seconds. 0.148 seconds. And This is not necessarily going to be equal to the time that you get if you take the average first and then figure out what the time is. Basically, if you took this one, 0.11, and you multiply it by 2, and you divide by 9.8, you get this number and a square root. They're close, but not exactly the same. You can almost use this as a sort of double check, but I would maybe not recommend doing it this way because you could be led astray by wanting to then say, oh, well, it must be 0.15. If you only rounded to two significant figures, then yeah, sure, it's still 0.15, but you can see that there is some difference. And some of that can be attributed to round off error. Some of that is actually due to some other basically discrepancies in what's called the propagation of errors that I don't really want to talk about in today's video. But in any case, your answer here should be 0.148 seconds. So then when it says enter this time, you would enter into the box that's given 0.148. You would not enter the seconds into the box, even if it says answer in seconds, which I probably should have made it say that. You would just answer 0.148. You don't add the units afterwards, or else Blackboard will mark it as wrong. Before I move to the next one, here is the actual answer that I entered into Blackboard as the correct answer. Here's the range that I put onto that. The range basically means that for this problem, if you enter anything between 0.148 minus 0.008 and 0.148 plus 0.008, that Blackboard should be counting it as correct. So if you put as your answer 0.140, Blackboard should mark that as right. If you put 0.15, Blackboard should mark that as right. If you put 0.156, Blackboard should mark that as right. If you put 0.157, Blackboard should say, no, you're wrong. So that's just kind of an interesting factoid for you. So let's look at the next of the questions on here. This next question was, suppose you drop the meter stick and it falls 25 centimeters for your left hand, but only 15 centimeters for your right hand. How much faster was your right hand reaction time than your left hand reaction time in seconds? And calculate this to at least 3 decimal places. Notice if you look at the answer that the 0.009 and the 0.0509 means that I kind of tell you to do it to 3 and then it turns out that you only needed 2. But really, with these number of significant figures, you should be able to get 3. So let's go ahead and calculate this and see why it's this much faster. Alright, so I'm going to begin by giving labels to stuff. I'm going to call this the distance that it falls for the left hand, so dl. I'm going to call this the distance that it falls for the right hand, dr. And what we want is how much faster your right hand is than your left hand. So again, if we use the time formula that's given in your handout, time in seconds is 2 times distance in meters divided by 9.8. So what that means is that we need to convert these into meters. So that means move the decimal place over 2 spaces. So this is 0.250 meters. This one is 0.150 meters. All right, now the times. So this will correspond to TL, this will correspond to TR. So time for left, and that is TL, is going to be square root of 2 times the distance for the left hand divided by 9.8. And again, this is in meters, and this will be in seconds. So pull up the calculator. The order that we need to do this in, I should probably put the numbers in so that you see it again here. It's 2 times 0.250 meters divided by 9.8 meters per second squared. So now I'll put in the numbers. 2 times 0.250 should be 0.5, and then that divided by 9.8 gives you this number, 0.05102, blah blah blah. Take the square root and you get 0.22587, etc. So I'm going to basically call this 0.22588 seconds. And I'm basically keeping more decimal places than I need because I know that I'm about to subtract two numbers from each other. So until I've calculated this one, I don't necessarily know how many decimals I'm going to need here in order to have 3 decimal places in my answer. So now we'll do time for the right hand. So time for right hand is going to be TR, and that is square root of 2 times dr divided by 9.8. This is an r. So that's square root of 2 times 0.150 meters divided by 9.8 meters per second squared. So now we need to put that number into the calculator. 2 times 0.150 divided by 9.8 gives us this. Then we got to take a square root. That gives us this. So this is 0.17496 seconds. Alright, so what we want is how much faster is the right hand reaction time. So how much faster? I'm going to represent that as delta t. So delta t is equal to the difference in the two times. So that would be TL minus TR, or 0.22588 seconds minus 0.17496 seconds. So we can put that into the calculator. 0.22588 minus 0.17496 gives us this difference, 0.05092. So delta t is 0.05092 seconds. So out to 3 decimal places, it didn't say necessarily 3 significant figures. 3 decimal places would be to here. 3 significant figures would be to here. And again, the way that you'd actually enter this, even though it says in seconds, is there's a blank space to enter your answer, and you put 0.0509, and then that's it. Then you enter that. No units, and it should be marked correct as a result. So again, that matches with the correct answer. If you put 0.051, that's fine. You're within the margin of error. Okay, so let's look at the third and final one that I'm going to work for this particular quiz. It says, suppose your right hand has an average reaction time of 0.15 and your left has an average reaction time of 0.25 seconds. What is the percent difference between these two? You do not have to enter any plus, minus, or percent signs. So let's go ahead and open up the basic instructions, and you can see here that the percent difference is given. PD is y minus x over y plus x over 2 times 100%. So this is the thing that it's asking for. We want the percent difference between the right hand and the left hand. So the equation says that PD is equal to y minus x over y plus x over 2. Okay, so this over 2 part we could have written, for example, as divided by 2. And then that's times 100%. So what are x and y? Well, this one represents x, this one represents y. The order doesn't really matter because for this question it says do not enter plus, minus, or percent signs. So if you put the order backwards, you're going to get the same number with a minus sign in front. You can just remove the minus sign because that's what the instructions tell you to do. So if you choose to call this y and this x, you're going to get the same answer as I do at the end of the day. Therefore, percent difference is 0.250 seconds minus 0.150 seconds divided by 0.250 seconds minus, plus 0.150 seconds. And then that is times 100%. Okay. So the difference between these two is 0.01. So we have, is 0.1. So 0.100 seconds divided by 0.25 plus 0.15 would be 0.4. And this is divided by 2. So we have 0.4000 divided by 2. And that's times 100%. So 0.4000 divided by 2 would be 0.200 seconds. 0.1 over 0.2 is the same thing if we were to move the decimal place over by 1 as 1 over 2. So that would be 0.5. So the percent difference is 0.5 times 100%. That is 50%. And actually I shouldn't put a box around that because so far I have been saying just put the number in to the box. So really you would enter 50 into the box for your answer. And you can see that the answer that I have here is 50. In this case, I put plus or minus 0 because here there's no room for you to make a round off error. You either did this right and you got 50, or you did it wrong and you got something other than 50. Usually I have some round off error allowance because usually the numbers don't work out quite this nicely, but every once in a while this happens. So there you have it. Those are, I believe, the 3 most difficult questions on this quiz as measured by how many points people got on average for them. These were the 3 on which people averaged the least number of points. And so I hope that you found this helpful for the purposes of your reviewing and learning this material a little bit better. So good luck on the next quiz, everybody, and thanks for watching.